Hi, I am Hamad. I will explain how to perform the tensile test and describe the characteristics of stress and strain diagram. So I advise you to join me in this journey. Okay? We will start. The tensile test is a very common mechanical test which takes a specimen and stretches it along its length until the specimen breaks. It consists of upper moving part and lower fixed part with a holder and control unit to give you the result of the test. This is our specimen. Before starting, you should find the original diameter and the original length, which is the distance between 2 points. You punch it in the outer surface of the specimen. And also, after you finish the tensile test, you should find the final diameter and the final length. Okay. After that, switch the testing machine on and place the specimen on the holder and start the test. Now the main output from the tensile test is the stress strain curve, which describes how much the material we are testing will deform for different levels of applied stress. Watch how the stress strain curve evolves as we perform a tensile test on our specimen, which in this case is made from mild steel. As we see here, the first part of this curve, it's linear. After that, there is a curve. Now, if we figure out the stress strain diagram, we can find that stress represent in y-axis and strain in x-axis. Stress equal force divided by cross-sectional area and its unit Newton per meter square or Pascal. And strain equal elongation divided by the original length without dimension. The first characteristics in this diagram, as we will see, the proportional limit, which represent the end of linear relation between stress and strain in elastic region. After that, the second point is yield point, which represent the beginning of plastic region and the end of elastic region. This point, yield point. We can observe that the curve split into two regions, the elastic region where the curve is linear and the plastic region. If we remain in elastic region, the original dimensions of the specimen will be completely recovered when the applied load is removed. For plastic region, a permanent plastic deformation will remain after the applied load is removed. Here, the ultimate tensile strength, which is the maximum stress during the test, and the necking area will begin on it. After that, we will reach the last point, which is fracture point, which means that the specimen will break. This point. Finally, the area under the curve, like here in the yellow line, it is the toughness of a specimen. Now there is a question for you. Why is steel used to construct bridges? I hope you will find answer after this video. Hooke's law gives us the relationship between stress and strain in this linear elastic region. The ratio between stress and strain is Young's modulus, also called modulus of elasticity, and it has the same unit of stress. It is a capital E, which equals stress divided by strain. Now we will investigate different types of diagrams. The first one for ductile material, this blue one, like mild steel, copper and aluminium. The second one, yellow, for brittle material like cast iron and glass. We can observe that there is no necking area. As you increase the load, you will reach the fracture point direct. The third one, red, for more ductile material like rubber polypropylene. The fracture need more times than the normal ductile material. To conclude the video, we find that in engineering design, a common objective for many different applications is to keep elastic deformation as small as possible, which means that Young's modulus is a key parameter that need to be considered in the material selection process, as we see here in this example. Thank you for watching.